Okay, now we're talking about the method of p-value in inferential statistics, and we use the same example. So are psych students cleverer as compared with the general population of the students? Then we have defined the parameter of interest, which is the average IQ score of all psych students, the population that we are interested in. And then our null hypothesis is the psych students' IQ score is the same as the rest of the population. Our alternative would be the psych students' IQ score is higher. So that would be the H naught and H1. And then the observed value was X bar equal to 107. 5% significance level. Comparison distribution is something that a lot of students have problems with. It's a distribution that we look at the observed value on that distribution. And if you remember on week 2, we said that with the characteristic of the distribution is can be known by the mean and the standard deviation. And then in the next step, we said that if we have got population of individuals, then you have mu and sigma. But then when you have got, the next step was if you have got a sample of size n, then you, instead of sigma, you have to talk about sigma of X bar or standard error, or SE they call it, and that is a standard deviation of the X bars. So the comparison distribution here would be X bar is normally distribution, mu is the same as 100, but sigma would be sigma of X bar or a standard error, and that would be 15, which was the sigma of population of individuals, divided by square root of the sample size. Here sample size was 25. So sigma of X bar was equal to 3. Okay, and then because our observed value was 107, then we changed 107, transformed it to the Z score, and that became Z was equal to 100 X minus mu divided by sigma of X bar, and we got the value of Z is equal to 2.33. All right, in the previous slide, I just had 0.3 said 2.65, but it is 2.33. Now, if we go to our normal tables, we will see that okay, so how I should do it before I show you the normal tables. Let's draw this one. So what I do here, I will have my distribution. I will have a normal distribution, and then the Z score here would be if mean is equal to 0, then I have got my observed value. Instead of 107 for the raw score, I change it to the 2.33. All right, so I will have my observed value as 2.33. All right, so I want this area, which is the probability of Z greater than 2.3. Why is this area but not that area? Because my alternative hypothesis is greater than. So I need to refer to the tables and look at the probability to the tail for the value of 2.33. Now the Z score of 2.33 is in here, and percent in the tail is 0.99, not even 1%. So it is in here. All right, so it is 0.99%. So my p-value, I can just, it is approximately, let me say 1%. P-value is less than 0.01. Okay? So, by doing so, here we say that my p-value is less than 0.01. And remember that if you wanted to do cutoff score, your 2.33 here, 2.33 was greater than your cutoff score of 1.645, which was the cutoff score for 5% significance level. But now we are looking at the p-value, and we got the p-value from the tables, and it was less than 1%. So what did we say? When the p-value, which is the probability of observing what we have observed, or even more extreme in the direction of alternative hypothesis, so this area is less than 1%. Because the significance level is 5%, so you comparison of 1% and 5. Because 1% is less than 5, then we say we have enough evidence to reject the null hypothesis, and we say that the IQ score of psychology students come from a different population with the higher IQ. So we have done the rejection region and the p-value method. And in my next video, I do the estimation. Thank you.